When you look up at the night sky, it's easy to feel small. But what's far more unsettling is how big everything really is. We live on a tiny planet, orbiting an average star inside one galaxy among hundreds of billions. And that galaxy itself is just one drop in a cosmic ocean. So here's the real question, not if aliens exist, but where they are most likely to exist. Because when you run the numbers, when you strip away science fiction and focus only on physics, chemistry, and probability, something becomes clear. The universe is not designed for emptiness. The same laws that created life here apply everywhere. The same elements, the same energy, the same time. If intelligence emerged once, it can emerge again. And if it can emerge again, it probably already has. The universe isn't quiet because it's empty. It may be quiet because we're just beginning to listen. If we want to understand where aliens are most likely to exist, we have to stop thinking emotionally and start thinking statistically. The universe doesn't care about what feels unlikely to us. It only responds to numbers. There are more than 100 billion galaxies in the observable universe. Each of those galaxies contains hundreds of billions of stars. And what we've learned in just the last few decades is this: most of those stars have planets. Not a few. That means the universe contains trillions upon trillions of planets. Now think about Earth. Life appeared here almost as soon as conditions allowed it. As soon as the planet cooled, as soon as water became stable, chemistry crossed a threshold and biology began. That matters. Because it suggests life is not a miracle event, it's a process. Given energy, time, and the right ingredients, matter tends to organize itself. When you combine that with cosmic scale, probability changes completely. Events that seem impossible on a human timescale become inevitable on a universal one. You don't need life to be common. You only need it to be possible. Even if only one planet in a billion develops life, that still leaves billions of living worlds. And intelligence? That's a harder problem. It took Earth billions of years to produce it. But again, time is something the universe has plenty of. Stars burn for billions to trillions of years. Entire civilizations could rise and fall while galaxies barely change. This is why the real question isn't, do aliens exist? The numbers already suggest they should. The real question is where and whether we're looking in the right places at the right time. Because once you understand the scale, silence doesn't mean emptiness. It just means distance. Once you accept that life is likely, the question becomes more precise. Where exactly should we expect it to exist? Life doesn't need much, but it does need a few critical things. Liquid water, a source of energy, and enough stability for complexity to emerge over time. That immediately narrows the search. Around most stars, there is a region scientists call the habitable zone. Not too hot, not too cold. A place where water can remain liquid on a planet's surface. Earth happens to sit in this zone, but is far from unique. In fact, many of the most promising worlds may orbit red dwarf stars. These stars are smaller and cooler than our sun, but they're also incredibly long-lived. Some will burn for trillions of years, giving life far more time to develop than Earth has had so far, and red dwarfs are everywhere. They're the most common stars in the universe. Then there are planets we never expected to consider. Not planets with oceans on the surface, but worlds with oceans hidden beneath kilometers of ice. Moons like Europa and Enceladus, where tidal forces heat liquid water in complete darkness. No sunlight, no surface life. Just chemistry, energy, and time. And these environments may be far more common than Earth-like planets. Some worlds may have thick atmospheres that protect life from radiation. Others may have global oceans. Some may not resemble Earth at all, yet still support biology. The important insight is this: we're not looking for copies of Earth. We're looking for places where nature has enough freedom to experiment. And the universe is very good at experimenting. If life can exist in these environments here, there's no reason it can't exist in countless others across the galaxy. This is where the search becomes serious. And also, where it becomes very interesting, there's a deeper assumption hiding beneath everything we've discussed. An assumption that alien life should look familiar. That it should breathe air, live on the surface of planets, and depend on sunlight. But life doesn't care about our expectations. On Earth itself, life thrives in complete darkness, deep beneath the ocean, near hydrothermal vents, powered not by sunlight, but by chemistry. That means alien life could exist beneath ice, inside oceans we never see, or in environments that feel completely hostile to us. Some worlds may host life in thick atmospheres, protected from radiation. Others may support biology floating in clouds or living under immense pressure. And some life may not be biological at all. Advanced civilizations may outgrow fragile bodies. They may transition into machines, simulations, or digital minds, forms of intelligence that don't require planets, water, or even stars in the way we do. At a certain point, intelligence may stop adapting to nature and start redesigning it. And that brings us to a final question. If the universe is so large and life so plausible, why haven't we found anyone yet? This is the Fermi paradox. One possibility is timing. Civilizations may rise and fall in cosmic moments, missing each other by millions of years. Another is distance. Signals weaken, space is vast, silence travels well. Or maybe advanced civilizations don't broadcast. Maybe they turn inward. Or maybe they've learned that staying quiet is safer than announcing their presence. The absence of evidence is not evidence of absence. It may simply mean that the universe is more subtle than we expected. And perhaps the most unsettling thought of all is this. We're not alone. We're just early. Still learning how to listen. In a universe that has been speaking for billions of years,